Hello, dear viewers. My name is Mark, and I'm here to present my assignment that's about two philosophical questions. One being, can computers think? And the second one being, are we able to make computers that are able to think? So I hope you enjoy my presentation so we can dive into the discussion. So before we can dive into the discussion, you have to first understand what the term AI means. What's an AI? For those who don't know, the term AI in full is artificial intelligence, and according to the Cambridge Dictionary, it means the use or study of computer systems or machines that use the qualities that a human brain has, such as the ability to interpret or and produce language in the same way that seem human, recognize or create images, solve problems, and learn from data supplied to them. So basically, an AI is something that receives tasks that without memory requires some human level of intelligence to achieve. Things like communication, facial recognition, and other things. And I could use so many examples of AIs, like for example, the large language models like ChatGPT or Gemini that are able to communicate human beings, or they are the AI models that are in streaming services like Netflix or TikTok, how they're able to know your video preferences, or how self-driving cars are able to recognize signposts, dodge obstacles on the road, and detect human beings. Context, I want to be referring to my AI project, which is about an air quality monitoring system. And what this system does is basically it uses sensory data such as the amount of pollutants in the air, humidity, temperature, etc. if possible, and with the help of AI prediction and user feedback, it will be able to generate air quality scores and restaurant recommendations that will help customers decide on where to eat and also help restaurant owners um, to improve their service delivery and make a better environment for customers to eat in. So the first question I want to discuss today is, can computers think? This question on whether computers can actually think all depends on how we define the term to think. Does it simply mean to show intelligent behavior like reasoning, learning, perception, or decision making, or does it require something more complex like exhibiting creativity, intuition, or consciousness? So Alan Turing found a way to answer this question by reframing a similar question: can machines imitate human behavior? Where he proposed the imitation game, claiming that if a machine can respond indistinguishably from a human in conversation, it appears to think. In other words, if you can have a text conversation with a computer and you can't tell whether it's human or not, then it passes. That was the whole essence of the imitation game. What we call today the Turing test. And if a machine has passed the Turing test, then we would regard it as one that has been able to achieve thinking. But not everyone agreed with this reasoning. In 1980, John Sear challenged this view, arguing that computers manipulate symbols but do not understand meaning or semantics. He gave an example of a person inside a room who follows rules to respond to Chinese without knowing the language, and he concluded that the person in the test does not equal to true understanding or consciousness. In other words, the best his example means that you get an English speaker and put him in a room, give him a Chinese dictionary, and then people keep on passing him Chinese, and then you respond back with English. To the outside, it looks like the person actually understands Chinese, but does he? Does he actually understand Chinese? Just like in the same case as my AI project. The system processes sensory data such as carbon dioxide, humidity, temperature, and user feedback to produce AI scores, which to the user makes sense, but does it actually understand what it's doing, or is it just following predefined rules and algorithms? So from the previous slide, we talked about whether our computers can think, but now if to dive into a deeper discussion, we have to ask ourselves, what type of thinking do they have? And that's why this discussion of weak versus strong AI comes in. Because John Searle, when he first introduced this and defined strong AI as a machine that, when appropriately programmed with the right inputs and outputs, will thereby have a mind precisely in some sense human beings have minds. Many define weak AI as a simulation of thinking or models what models humans' cognition without actually understanding or have awareness. So now, if a computer shows intelligent behavior, but only within the bounds of its ground. Does it mean it thinks, or is it just mimicking intelligence? So to return into the context of my project, if where the system records environmental data and uses this data to come up with air quality scores, safety alerts, and restaurant recommendations. So can we say that the computer even understands the significance of high levels of carbon dioxide to a human? Does it even care about the safety of a human being? Or does it even understand the significance or impact of this recommendation to the well-being of a human being? Me, I say it doesn't, because sugar still remains a theoretical possibility, and therefore, even if an AI shows some level of intelligence, it still lacks true understanding and intelligence. Therefore, I conclude that all artificial intelligence right now are still weak AI. So, learning versus memorization. So, we have to ask ourselves, what's the difference between to memorize and true learning? Well, memorizing refers to storing information exactly as it is without understanding what it means or how to apply it. While learning, on the other hand, this involves adapting, understanding, or applying knowledge to new or different conditions. An example of this is a student who's trying to cram for a paper the next day, and then when they go to that paper, they actually pass. So would we say that the student actually learned the topic, or he just memorized and reproduced those answers? Because learning would require you to understand the topic, and even if you're given a new problem, you'd be able to answer that. So if we return back to our computer, we have to talk about machine learning, and then we have to ask ourselves, do machines actually learn? The truth is they don't. Their learning is more of statistical and it's not conceptual, because they they find patterns and correlations in vast amounts of data, but they do not grasp the abstract ideas or the underlying meaning of the data that they're trying to learn. They lack the contextual understanding humans use when applying the knowledge. So the best to explain this is in the context of my project, where an AI system is monitoring air quality in restaurants, especially live data of the amount of carbon dioxide and the air quality flowing to the restaurant. And then one evening, a family decides to enter, and at the same time, the staff is trying to close the windows and doors to prevent noise pollution. So then, when that happens, suddenly the air quality becomes bad. And then the AI in this case will suddenly blame the people who have just walked in, because that's what it has learned. Because it doesn't have the common sense to understand that by closing the windows and the doors, that could have been the reason. It's basing off all its knowledge on only the people, because that's what it has learned. It's learned that every time somebody enters, the air quality will become bad. So it's gonna relate that information to the people who have entered. And that's where, and this problem we call it a frame problem. And that's the main problem with machine learning. Yes, it's a powerful tool that helps us estimate information and predict, but it doesn't actually it doesn't actually think, and these are the problems we face. It's just a sophisticated way of memorization. Multiple intelligences. So for a long time we've associated intelligence with just one thing, but Gardner challenged this by saying that intelligence isn't just one thing, but a combination of multiple intelligences, A to be exact. And AI can simulate some of them, or it can simulate others. It's good at simulating some intelligences like logical mathematical intelligence, naturalistic intelligence, visual spatial intelligence, linguistic intelligence, sometimes even bodily intelligence. But however, AI has not crossed the barrier of personal intelligence, which is basically interpersonal intelligence and intrapersonal intelligence. And until it crosses that barrier of, it can never consider to be able to think. So in the context of my AI project, the AI can only simulate mainly three, but also occasionally one of them being mathematical and logical intelligence, where it uses data mining and statistical analysis and prediction algorithms, naturalistic intelligence, and spatial intelligence, which basically track the pollution and in an area in a 3D map, and then it partially simulates linguistic intelligence by communicating to the customers through recommendations and ASCA, but it cannot simulate bodily intelligence and interpersonal intelligence and also intrapersonal intelligence, because it doesn't communicate physically with the environment, and it lacks emotion. It cannot process human emotions and self-awareness. So the next question I want to talk about is whether we could have a computer that is able to think. So the way AI is roughly advancing, the idea of a thinking computer is actually very possible, because AI right now can achieve very complicated tasks such as voice recognition, facial recognition, and others. So with today's capabilities, AI can actually achieve very specific predefined tasks but still lacks the adaptability, the awareness, and emotion. An example of an AI that monitors air quality, the AI can, when the air quality suddenly becomes bad, the AI won't understand how the people feel in this case because it can't process emotion. So AI still has a long way to go. So the question still remains whether it can create an artificial general intelligence that will be able to think and adapt to new information. But the closest we have got to this is to deep learning models that can automatically learn and iterate patterns and continuously learn over time. So before we can even start talking about creating thinking computers, there's still some barriers the current AI has to overcome. One of them being the problem of consciousness, the hard problem of consciousness. So David Chapman suggested that if we design computers that appear intelligent, we still don't know how to make them feel or be aware of things the same way we do. Things like experiencing colors. And this was also backed up by John Searle's Chinese room argument that further shows that simple manipulation cannot be the same as genuine understanding or consciousness. Another problem being the film problem, because AI fundamentally lacks human-like common sense or understanding to filter relevant from relevant information. The best example I can give is the one I gave earlier of how a family enters a room, and an employee closes the windows, but the AI still flags as the family being the cause of the problem, yet they've just entered the room. So, yeah, uh, so AI still has a long way to go because it cannot have this simple common sense of distinguishing that this problem is more relevant than the other problem. Uh, so now potential pathways towards thinking computers, one of them being neural networks and connections. So AI system being designed the same way human. This is basically talking about how AI systems can be designed the same way the human brain is designed, just like our neurons in the brain. This approach uses artificial neural networks to allow learning and experience. If more advanced networks are built, we may get computers that can learn and adapt in the same way human beings do. Then there's another argument of the simulation problem. In 2003, a philosopher called Nick Strom suggested that if civilization became capable of creating consciousness, it would generate so many that any one single entity would certainly be in a simulation. So now, if this argument was valid, then it could be theoretically possible to create a computer because if now you wouldn't know if even like us ourselves, we don't know if we're in a simulation or not. So if we are, then it's possible even us ourselves can create a thinking computer. So, but this still remains an hypothesis and it's not confirmed. So it's still a potential pathway to creating thinking computers. Ethical implications. So there are very many ethical things, such as if an AI were able to reach the level where it could think and make its own decision, what would stop it from making choices that would harm humans or violate privacy or cause economic damage to a business, and what measures are being put there in place to regulate this? But all these are questions we ask when AI has reached that level of thinking. But as for today, AI continues to advance into new different fields such as healthcare, law enforcement, and finance, and their risks also continue to grow. Like, for example, in the context of my AI project, there's one ethical concern such as data bias and inaccuracy. Since the system relies on user input, which is different from user to user, one user may say that AI is bad, some may say it is good, but the AI may flag, since it doesn't know which is valid, it may flag all of it under one user, which creates inconsistency. Then there's a problem of privacy, where, especially in a small establishment, where the data can easily be tracked back to one person. So this breaches what confidentiality. So, in conclusion, computers do not currently think the same way humans do, and the arguments from Searle, Gardner, and Chalmers firmly distinguish this simulation from genuine understanding, consciousness, and multi-phased intelligence. The pursuit for strong AI remains a profound theoretical and technical challenge, especially with these philosophical barriers that it's facing currently. And the ethical aspect is also crucial. Building systems that are not only just reliable but consistent with human values. And that's also has to be a top priority when we're creating increasingly more sophisticated AI. But for now, an AI is a powerful tool and a mirror of our own intelligence, but it's not yet our mind. So I would like to end here. Thank you for listening to my presentation.